So this week we're talking about mechanicals. So we are installing our ductwork and HVAC. We're also doing plumbing, and then followed behind that will be electrical. You guys have seen in previous episodes that we've coordinated that. I want to introduce you to Mike over at AGS. This is Mike. Mike, nice to see you.
Nice to meet you.
So, well, we've met before. So Mike is on site. They are installing all of the HVAC for this project. Mike, one of the first things that we had done on this is a coordination meeting. Julie had marked out and coordinated the entire job. We got on site and walked through where everything was going.
Correct.
How important is that in residential, and how often are you guys typically doing it?
It's very important. It's nice to have the job meetings, especially with the architect, your plumbers, your electricians, because I'm the type of guy I like to be first. I like to be in there because in this particular case, because the house is so small, I want to say small, but tight, well designed, we need to make sure that everything that we're doing with the airflow and the ductwork is created properly and installed properly. So here's the key to that. But the job meetings are very important. That's something that we like to do as well too. Coordination.
Do you see a lot of the homes being modeled the way that we did it here?
Yes and no.
Yeah.
Yes and no.
And that's something that we push for. Like, we want to be modeling our entire home and trying to find locations for it. You just actually made a great point, is you guys going first. Typically that's, in order of operation, the largest, right behind that is the plumber.
Correct.
And you said coordinating with the plumber. You guys have been coordinating amongst each other to make sure that, there's some tight plumbing and ductwork above here.
Correct.
And that, that coordination, and then followed behind is the electrician.
It makes everybody's job easier. It makes the project go a lot more smoother.
So in a tight home like this, everything that I've seen you guys install is all sheet metal.
Correct.
And a lot of times I'm seeing in other projects, not necessarily our projects, but in projects in general, there's a lot of flex duct because it's easy to run. You can kind of manipulate it where you need to.
Yeah.
What is the importance of using sheet metal, and how are you getting this stuff fabricated?
Well, we have a full fabrication shop. Both Paul and myself, we've been fabricating ducts since we've been out of high school. So yeah, today a lot of guys will use flex. It's a way of cutting your time down on a job site, or trying to move it along a little quickly. Flex is not a bad thing, but it's also not a good thing.
Sure.
Flex is good if we're using it in short increments, so 5 feet less. Other than that, we want to use round pipe. We want to use round pipe any time that we can, but a lot of times we can't because we don't have the space, so we go into square.
What's the reason for wanting to use round?
We're going to get better airflow out of it.
Oh, interesting.
So your air is not going to be bouncing around.
Gotcha.
We're going to be nice and smooth. We keep our noise level down going through the duct. So those are all factors that.
And that's something I hear about using flex in oftentimes, generally speaking, you try to get a trunk line up in the attic or the basement or whatever that may be. And when you go to a register, you actually want to switch to that flexible duct to kill some of that sound.
Correct.
Right?
Correct.
So
but you want to keep it minimum.
5 feet.
Right. You want to keep it minimum.
So we're looking at here, you got ductwork going up. You fabricated all this stuff in your shop.
This is all,
you unloading it out of your truck. You're getting it up there, you're coordinating with the plumber. But downstairs, you got some tight work as well.
Yeah.
Why don't we head down there?
Sure.
So how many air handlers do we have on this project?
We have a total of 2.
2. And then a permanent fireplace, right?
Permanent fire. That's to keep the boss warm.
The boss,
The boss warm. So this is a Mitsubishi high static air handler. So it's pushing anywhere from 1 to 3 inches of column static pressure, water column static pressure.
Yeah.
So we can move the air. The thing I like about Mitsubishi is the cabinets.
Yeah.
They're very insulated well. You're not going to get a lot of leakage out of it. And that's a big factor when it comes to ductwork and cabinets.
And this is fed by an air source heat pump outside.
Correct.
And that's for heat and air conditioning.
Heat, air conditioning, and dehumidification with Mitsubishi. So.
Gotcha. So there's no need for a dehumidification system in addition to, or?
No, you definitely can do a dehumidification as an addition. Most of your high wall heads, ceiling cassette units, they're going to dehumidify, or they have a dry mode.
Sure.
With the air handlers, you might want to add that
Sure.
dehumidification, that extra dehumidification, which we're doing in this particular case.
Gotcha. So this is, correct me if I'm wrong, this is considered a ducted mini split system.
Correct.
Gotcha.
Correct.
And one thing we talked about in the last episode is getting plywood up on the walls, basically setting you guys for a good stage. And you guys, and I was talking to your son last time, but everything coming out nice and neat, all your sweeps done, up and out. And I know Brian, our super's done a really good job of locating everything, making sure you know exactly where it goes.
He's been fantastic coordinating things with us. A lot of, we could have came in here, dropped all the equipment down, but we would have ended up killing the plumber because he wouldn't have been able to get in after we got
Sure.
in. And the same thing with the plywood. We want the mechanical room to look,
Right.
Picasso,
Right.
as I would say to my boys, Picasso. So we want everything to look neat, like it's made to be there.
Sure.
So, and the boys do a nice job. As you can see, everything is clamped down. Their radiuses are all nice. Everything is nice and neat.
It's important to me. I agree with you. The Picasso mentality, where it's like you want to be able to take a photo of this and have it look good.
Correct.
But even like simple things like the nice sweep in the control wire, like you said, everything clamped, everything nice and level, plumb. Even the ductwork, where you guys are pre-insulating this before it even gets on site.
Yes.
So you're getting these, upwards of maybe 4-foot chunks. No tape. You're not taping up thermostat wiring on the outside of
No.
it. Everything
No.
is nice and neat.
No,
So this is air handler number 1. What is this feeding? Just the first floor?
this is going to feed the first floor.
So this is going up above most of our ceilings, and
Yep.
then we have some plastered in registers as well as some Hart and Cooley, I believe.
Correct.
Surface mount system.
We got, which something that I like that Jillian did was that we have the linear diffusers because the front of that building is all glass.
Right.
So that's one continuous linear diffuser.
Right.
And that's going to be an extra. Plus, it's nicer. It's more aesthetically pleasing, the linear diffusers.
So what Mike's talking about is that on that first floor where we have that giant glass wall, that return, that 90 return, that entire wall is actually going to get a built-in shade pocket, but just behind that we actually have a linear diffuser that will run that entire length.
Yep.
How important is it to wash the window with your conditioned air?
Well, it's very important. When you got such a beautiful view out there, you get a nice window. Last thing you want to do is wake up in the morning and it's all fogged up or it's all condensation down. So, because we got cold temperature outside, warm temperature inside, or vice versa. Cooling season, we're cold, warm and humid on the outside. So you want that glass nice and clear. We're looking out to a beautiful view. So if we're putting that linear diffuser right in front of that glass, we got that air going down. We get that perfect temperature where we don't have that condensation, fogging up or any of that. Nice clear view. So
it's not only that, but it's also you're basically, if you were to get coldness, right, temperature drop on the inside of that glass, you're basically combating it immediately.
Correct.
And then what you're doing is you're supplying your conditioned air at your outside envelope, and then you're pulling that return somewhere centrally located. So you're basically pulling, across that room, and ideally you're getting that perfect temperature
correct.
control.
We're taking everything from the outside of the house, which is basically your heat loss and your cooling loss, and we're bringing that all back in. So we know that the outer part of that house is at a temperature that we need to maintain so that we don't have sweating windows,
Right.
We don't have fogging windows, and we're bringing everything back into the center of the house. So we got great airflow going through the house all the time.
Yeah.
We don't hear it, we just feel it.
Right. And one thing to note, this is a passive home. The HVAC has actually been engineered. We work with Ross over at T2 Engineering.
Yep.
He's helped us develop and understand what systems are required, and also making sure that, and I'm sure you've run into it, we're not over designing the system. A lot of these homes have these massive HVAC systems that are just completely oversized, and they're not, you end up not being as efficient, and you're wasting energy.
Absolutely. Years ago, when we first started off in the trade, it was every house had 100,000 BTU furnace in it, and that was it. Today, with the passive houses, and we're so tight, we're adding ERVs, so we're bringing fresh air in. Now we don't have to have such a huge heating and air conditioning system to heat or cool a home. So it's important that we're doing heat loads, we're doing duct calculations, because we want to be energy efficient. That's the whole key to this.
Right. So first floor, what are we doing on the basement level here? This basement is not going to be finished now, but we are going to be finishing in the future. So we're prepping it for the future, right?
Correct.
So where's that air handler?
Right. Spin right around.
So this is much smaller.
This is much smaller. This is what they call, that's a high static. This is what they call a low velocity. So it doesn't have the static pressure that one would, or move the air as quickly or as fast as what this will.
And is that because you have the stack effect in the sense of pushing air up to the attic and dropping it down?
Correct.
Gotcha.
Correct.
So this is feeding at level.
At level.
Yeah.
Yep. Ultra quiet. Just a nice piece of equipment as far as what we need to accomplish down here. It's almost perfect for the job.
Is this also a ducted system?
It is also a ducted system.
So this is why Julia's designed it without that middle stringer, because you have some ductwork that you got to sneak in here.
Correct.
So will you fabricate all this as well?
Yep. This is all being fabricated as we speak now. Hoping to next week we can get in here and start installing all the ductwork in this. This is a little bit more tedious than this one.
Sure.
Because we got attic space up there, so we got a little bit of room. But this here, we're down in walls, we're coming up in the chase. We're gonna end up have to drilling through some of the joists in order to get where our registers need to be.
Right,
so,
and that's all what Julia's designed is figure out where this ductwork has to be, which is why we don't have this center stringer under the stair. We knew that we could fit it on the backside. Mike, I have a question about outside. You have 2 condensers.
Yep.
My understanding is that they're Mitsubishi. They are Mitsubishi heat pumps, and my understanding is that you could run multiple units off of one condenser, but we have 2. What's the reasoning for that?
Multi-zone. You can only go up in the residential. You can only go up to 2 tons.
Okay.
I mean 4 tons. I'm sorry. Apologize.
Yeah.
4 tons. So I think we're doing 2 tons here, and I think this is a 12,000. But in this particular case, and you know, this was something that Ross, you know, it's just a better fit rather than doing one condensing unit with 2 separate units. We're going to get the full capacity and the full capacity out of that because it is a variable speed system. So it's not like we're going to have to pull from one for the other.
Sure.
It's just a better fit. A lot of people will do a home, they'll say, well, I want to do the upstairs and the downstairs with 1 unit, whether you do it in a mini split or you do it in a conventional system, and they don't zone it. And of course, what happens?
You overheat.
You overheat in one floor or you overcool. It's not the best way to do it. That's why we're always pushing 2 separate systems, one for upstairs, one for downstairs. So it's kind of in the same general category as far as a regular heating and air conditioning system with the mini split. We'd rather do one for the downstairs and one for the upstairs. It's just a better fit.
So, and that's been, like you said, Ross has designed it to really work, and we want, all of these systems are designed at peak loads. So when it's really hot, we know what our demand is going to be from a cooling perspective, and our cooling perspective down here is going to be much lower because we are subterranean for the majority of this foundation.
Correct.
Upstairs, that cooling load is going to be much higher. Same thing in the winter. It's those heating loads are going to be different floor to floor.
Correct.
But also we want to design in the peak, so that's why we're doing the 2 air source heat pumps.
Absolutely.
Last question I have is the ERV. You mentioned it a minute ago.
Yep.
Energy recovery ventilator. It's a system that we use to exhaust stale air and bring in fresh air from the outside. Is it my understanding that, you know, I've done it a couple different ways. I've done it where we dump in that fresh air into the ductwork for the 2 air handlers, but here are we doing something, it's a standalone system, is that correct?
It is a standalone system. So the way Ross designed it was that we're also going to be using it for exhausting the bathroom, exhausting the kitchen.
Yep.
So anytime that the bathroom light goes on or the kitchen exhaust fan goes on, anytime that any of the units call, the ERV will actually run at a very low speed consistently, but the minute one of these factors come into play, the ERV will bump up and stop. And when you're building a house so tight like this, it's important that we have a change of air in the building.
Yeah, so what you just said, when it bumps up, it's oftentimes called a boost switch. So when you're in that bathroom, it's going to boost that exhaust. So, you know, we don't have a huge demand for like the kitchen and things like that. We don't have a gas range.
No.
So we don't need a conventional hood. We just need a piece of equipment that is going to exhaust the stale air. But you made a great point, is that, you know, it is a really tight house. So running that ERV at a consistent level is constantly exchanging the air, so the air does not get stale within the home.
So important.
And, you know, one of the most common misconceptions is houses are built too tight, houses are built too tight. And the fact is, they are built tight and they do need to breathe, but breathing through an old leaky wall isn't the way to do it.
Correct.
Breathing through something like an ERV or an HRV is the way to mechanically allow the home to breathe. And now you have consistent, fresh, filtered air in your home, which ultimately is
the goal.
The most comfortable.
Build tight, ventilate right.
Love it. Mike, thanks so much, man. I appreciate it.
Thank you.
Guys, let's go check out upstairs. The garage is all framed. We have our roof above our breezeway. We'll step back here, actually. It's framed and they're sheathing it now. No overhang on the back here, but this overhang will be applied after the fact. When you flip to the front, you'll notice that the breezeway roof is actually higher than the main house roof. And that's because there's no insulation on this roof. And on the main roof, you'll have 6 inches of insulation. So that sheathing is actually 6 inches proud of the main body of the house. So once you sheathe the main body, everything will plane out. But we also have this product back here, which is a Benjamin Obdyke product, and it's a Slicker Max. So this is designed for our cedar shingles. It's an all-in-one product, so we can just staple this up. We're not worried about air tightness on this. We're just dealing with bulk water management. So we'll use this product throughout the entire garage. And then we'll tape our detail for our windows just like we did on the home. So Julia installed a second coat of this Proseco, and then from here we'll actually install our sheet metal flashing over the deck ledger, so we'll have that redundant water management where we have the Proseco on the first layer and our sheet metal on top. And once the sheet metal is installed, we can set and install this big glass door, which is just a few weeks away. We'll see you guys next week.